So we've got three main theorems we want to review. Just keep them fresh so that we, anytime they pop up, we can kind of identify or recognize when we're being asked about these three theorems. Anybody got one of them for me? Just the name would be fine. Which one? All right, MVT, the mean value theorem. Great. Okay, so we've got the mean. All right, another one? IVT, nice. The I stands for what, Zach? Intermediate. Okay, and we got one more. Which one? Nope, A, B, C, D, E. Okay, extreme value theorem. Okay, so what are the requirements? For sure, continuity is required. That's a no-brainer. The MVT is the only one that requires both continuity and differentiability. Has to be both. So if the question announces at the very beginning, this is FRQ, very common, f of x is both continuous and differentiable on the interval. If they give you the and differentiable part, you should have bells and whistles going off. Warning, 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 I might need to use the MVT. They will tell you it is going to be differentiable. It is a huge clue to the kind of theorem you may be asked to use. If all you get is continuity, you cannot refer to anything having to do with slope, because only differentiability guarantees you to work with something with slope. Okay, so keep your eye out for that. All right, purpose. They each guarantee something. The EVT guarantees a max or min, which is the extreme, actually a max and min, on a closed interval, A to B. Hey, Zach, from last week, what is important about those closed interval when it includes the brackets?
When it includes the brackets, it means that you have to check the endpoints.
Okay, awesome. So let's jump down. Do I check endpoints? Yes. Okay. Anytime you are asked to do an absolute max or min, that's the EVT, and you have to remember to check the endpoints. If the endpoints are one of the candidates, it'll be closed. That's a huge clue too. So when the endpoints include less than or equal to or greater than or equal to, you've got to check those endpoints. So the summary of this is to find an absolute extrema by comparing endpoints to any other critical points. So we saw this in an FRQ last week where we were talking about that, and there turned out to be three things. There was an endpoint on the front end, there was an endpoint on the back end, and there was a critical point in the middle. And you have to compare the y values of all three of those to find the absolute. Remember we talked on Friday about the language issue, about being difference of the absolute maximum is 2 or the absolute maximum is at 2. Those two, the difference in the language there. Make sure that you understand the difference between being is a number or is at a number. Okay, so that's the EVT crash course on that. The IVT. Okay, what does the IVT guarantee? Okay, the IVT guarantees an F value, an F of C, between any two f of A and f of B. Okay, it guarantees the existence of f of c in between any two other values. So if I give you 2 and 4, what are you guaranteed to have? 3. Well, what else? Anything between 2 and 4 is guaranteed if the function is continuous. If I give you -5 and 7, what are you guaranteed to have? 0 for sure, because that's important. Leela, why is 0, like, why did that jump into your mind? Because I gave you a -1 and a +1, so for sure, but everything else in between as well. Okay, so jump down to the little notes at the bottom. That this is most commonly used, but not exclusively, when endpoints have opposite sign. Because you can guarantee a 0. But it doesn't only have to be that. Okay, so it's most commonly used if I give you 2 endpoints. So f of a is 8 and f of b is -3. What's guaranteed? Well, you're guaranteed everything between 8 and -3, but most especially you're guaranteed 0 in between. Okay, so that's a huge one. Do you check the endpoints? No, because the endpoints are the ones that you're given already, so there's no need to check them. You're checking what's in between the endpoints. So it's not important to check the endpoints, it's important to check what's in between them. Okay. And so then our summary is that continuity guarantees all values between endpoints. All right, so that's the IVT. Last one. Because we have the bonus of differentiability on the mean value theorem, our guarantee has to do with f prime. And it guarantees that f prime is equal to the difference quotient of f of b minus f of a over b minus a. That has to do with the slope. So what it guarantees is that the slope connecting the endpoints equals the slope of a tangent line. So if you connected dot to dot from endpoint A to endpoint B and you connected that, that line would be parallel to the slope of a tangent line somewhere else on that, at least one of them. It might be multiple, but there would be at least one. Again, we don't check endpoints here, so that's a no. Another way that you could be asked about this is to use the word rate. In other words, they could say that you would be guaranteed that the instantaneous rate of change would be equal to the average rate of change. So the instantaneous rate of change is the derivative part. The average rate of change is the subtraction part, that those two are guaranteed to be equal.